Peace in YouTube. What is up, everybody? So I'm continuing my hardest math problem series here. We're up to part 3 of the grade 6 hardest problems. I'm probably going to be a part 4 to this because I'm running short on time today and there's still a lot of problems left, which is fine. It's better off to get these in bite-sized pieces. So, hi, I'm Greg from GregsTutoringNYC. I'm a tutor located here in New York City. And I pulled some of the problems that most of the kids get wrong on the New York State tests, and that's what we're using to decide what's the hardest math problems. However, this is not about New York, and this is not about tests. Okay, this is about trying to bump up your math game in terms of how to analyze a problem and how to do problem solving and how to do critical thinking and things like that. All right. What you need to do is as you watch how I'm solving these problems, and by the way, if you're catching this on the replay, how to analyze the problem. Okay, we're live. If you're catching the replay, you can certainly pause as I get to each problem and then continue on. All right. But it's important to look at how I'm analyzing the word problems, how I'm analyzing the illustrations, how I'm trying to piece the problems together, and things like that. All right? So I'm not going to make a long intro this time because we're running short on time today. So let's just jump in here with the first problem. I've already done grade 3. I've done grade 4. I've done grade 5 with their hardest problems. And I've already done 2 parts of this already, I guess. In grade 6, there will be a 4th part as well. So let me get rid of this, and we'll just start jumping into the problems. We're going to go maybe 45 minutes. I might actually go a half an hour today. And if I can, I'll go an hour, but I have a feeling I'm not going to be able to get there. And we'll just continue the rest as we go on. Just as a side issue, some of you are taking the state test this week in New York State and probably other states. Good luck. But again, I'm not doing this for state test prep. I'm doing this, we're looking at problems that enough kids get wrong, and we're trying to rip them apart and really try to understand what might be going on here. That's the obstacle. So any additional kind of nuances or mathematical prowess, things that you didn't know about. And on that note, on top of it, I'm trying to show you alternate ways to solve some of these problems, whether it's an alternate way of following a different mathematical procedure, or in some cases, some of these can be solved just through logic. All right, so let's jump in there. And remember, please subscribe to the channel. I'm going to pump out a lot more stuff, and I already have. I have hundreds of videos. And please smash the like button. Yeah! Okay. So let me get my pencil set up here. 1 second while I activate that. Okay, so we should be good there. Here we are. Okay, so the model below shows a division problem. Okay, so the model is this, right? The model is this whole illustration, both the number line and whatever is there below it. So let's look at that, right? We're not looking at what the problem is asking us to do yet, right? My focus on a lot of these is to start with the illustration so that we're really focusing on what might be asked and what is going on here, right? We're using our power of observation on a lot of these to get to kind of be where we need to be. Because a lot of you just zoom through these. You might be super smart in math, but you got to give it your time. You got to give it a few seconds. Now, some of you might say, well, not a test. We have to pace and you don't have enough time. First of all, I'm not going over these as if they're tests. The other thing is, okay, if it was a test, you still need to give it the time where you're analyzing it enough to even understand what you're being asked. There's no good doing a problem fast if you don't know what it said and if your answer is wrong, right? So with that in mind, we're going to look at this. We have number line 0, 1 through 3, 4. Cool, nothing weird there. We have this thing below it, okay, that there's a shaded and an unshaded, okay? On top of that, it also seems to have a darker line here, here, which is under the 1 and the 2, by the way, okay? And it looks like it's split into thirds, so this dotted line matches that, okay? So it looks like this strip of ribbon or something below here, and I'm calling this whole thing the strip of ribbon, is being oriented to line up underneath the number line, okay? So that this here is a third and this is 2/3, okay? And if you notice, that's what they're doing here. They're separating it. Each 2 is in 2/3. So if there was 3 here, 1, 2, 3, they're only grouping it as an A and a B kind of a thing, okay? They're taking 2 out of a group of 3, 2 out of a group of 3, 2 out of a group of 3. And then the last one seems to flip between the shaded and the unshaded. And that might be just fine, all right? So there's a whole bunch of delineations here. The number line is delineated by the whole numbers here, okay? It's also split up into thirds here. And then this strip of ribbon or whatever it is also split up by the solid lines here, but it's also broken into thirds. And then we have this thing down here, which is furthermore breaking it down into 2/3, okay? So what could be going on here? It is confusing. I agree with this. This is confusing, the way they presented it. And probably, I'm going to guess, the majority of you, no matter what state you live in or whatever country, because this isn't necessarily just about United States math I'm showing here. Grade 3 math is more or less still grade 3 math. We could argue that some countries might be more accelerated than others, or you might be in an accelerated class. At the end of the day, whatever is going on here, this division problem, that's what they're talking about, it's still a division problem, no matter how old you are or no matter what grade you are, okay? So I think we've analyzed this enough. We don't know where they're going with it. We can kind of make a guess that there's probably a division here, that this whole ribbon is being broken into 2/3 parts. So probably the divisor is 2/3, but that's a wild guess. I don't know where they're going yet, okay? So then it says which equation is represented by the model. Okay, so the model is probably what I just talked about, that the ribbon is being split into 2/3, and the only thing the number line gives us is that they lined up the ribbon with the number line. So it starts at 0, and they lined it up, okay? So within the spirit of all that, now that we've kind of understood where this thing is going and kind of coming from and going to, let's look at it. So the first thing says 2 1/3, and I notice that A and B look similar, okay? The only difference is this is 3 1/2, and this is 3 1/3. So it could be that A and B is the answer, and we have to choose between that half and a third, okay? Or so let's look deeper. So A and B are both using this, and let me change the pencil for a second, because we still have the answers split up into weird pieces, okay? So this is 2 1/3. That's 2 1/3. Okay, that's 2 1/3, and that's 2 1/3. All right. And then we notice, I'm going to use the same thing here, that 2 1/3 is right here. This is 2 1/3. Right, and I'll even leave and keep going, and I'll leave it at the bottom too. Because this is also a visual problem on top of everything. So it seems that the shaded area of the ribbon, what I'm calling a ribbon, stops at the 2 2/3 point. Okay? Okay? So it says 2 1/3, which is the whole shaded part, divided by 2/3, which is this little group here. That's these. Right? That's that. Divided by 2/3, divided by 2/3. It's telling us that the answer is 3.5. Now, if we go to 3.5 on the number line, it's right here. So either it means 3.5 units like that, and A is completely wrong, which probably means B is wrong too, because the only difference that we talked about there was the half versus the third. So this may be indicative that both A and both B are wrong. But let's look at it deeper. Let's try to understand it. So it says 2 and 1/3, which is the whole shaded part, divided by 2/3. So it's making something in groups. So let's number them. There's 1 2/3 here. There's 2 2/3 here. There's 3 2/3 here. And there's a 4th 2/3 here, but it only goes up to half of them. So there's a half. So that means there's 1, 2, 3.5 2/3. Is that what this is trying to represent? That this 3.5 2/3? I think so. That seems to be the model. So far A is good. B says 2 1/3 divided by 2/3 is 3.5. 3 1/3. No, that's this number here is 2 1/3. Okay, so they're trying to confuse you here. So no matter how you slice this, it's not B. Okay, C says 7/1. Where are they getting 7 from? They're getting 7 because if you number this 4, we already had 1 2 3, 5, 6, 7. So that's 7 divided by 1/3. So they are in thirds. Gives us 2 1/3. Right? Because 7/3 is 2/3. Right? 7/3 is 2 1/3. But 7/1 divided by 1/3 means we're supposed to, when we have division by a fraction, we multiply by its reciprocal. So 7 divided by 1/3 is actually 21. Okay? It's 21. Right? That's different than 7/3. This is a division. So it doesn't give us that. So C is wrong for that reason, for starters. It's also wrong because we're not taking 7 things and dividing them by thirds. We're trying to divide them by 2/3. So 7 is wrong numerically, and it's also wrong conceptually. And that's what they're shooting for here. When they say the model below, this is a concept, which is represented by the model, which conceptually maps what's going on here. So C is wrong twice. Okay, and then D kind of reverses things. It goes 2/3 divided by 3.5. So it's taking each little piece and dividing it by the whole shaded area here. That's just illogical. That's not what's happening here. Okay, so that's out. So let's go back to A again. It's the only choice that's left. And make sure you really understand what's happening there. So there's 1, 2 1/3 of a shaded ribbon, okay? And you're breaking it into 2/3 pieces. And it turns out that we get 1, 2, 3, and only half of this shaded in. So we get 3.5. So that's what's being modeled here, okay? And it almost, the number line throws a lot of this off. So what's being modeled? We took something that was 7/3, because 2 1/3 is 7/3, and we're breaking that into 2/3 pieces. So basically what we get is 7/3 I don't know how this tablet drew a 1 if I did a 3, divided by 2/3. Okay, so division by a fraction means multiplication by its reciprocal. So we get 7/3 times 3/2. Okay, the 3's cancel out, and that's equal to 7/2. And that, my friends, my wonderful 6th graders, is equal to 3.5. Which turns out to be what this bugger is. And yet, this problem is happily ever after. So there's a few ways to approach this. It's probably something you'd never seen before. So now that you've seen it, put it in the back of your brains. And then we'll just make sure we're still alive. Yes, we seem to be. There's a few people in the lobby again. Please like and subscribe. And we can, speaking of living happily ever after, we could have something cool going on. Into perpetuity. All right, and again, I'm probably only going to go about half an hour more here. So probably going to do maybe 4 more problems, because some of these are taking about 10 minutes each. So let's see if I can get this to fit. So we're going to look at the illustration. It's showing coordinate geometry. It's showing an XY grid. And it's only putting the numbers up by 2s. So what I'm talking about is this: the 2, the 4, the 6, and the 8. But this is 1, and that's 3, and that's 5, and that's 7. And it works the same way on the Y. This is -1. This is -3. So the first thing we do when we see a coordinate grid is to make sure we know what the units are. Because sometimes they may do something like this. Do 2, 4, 6, and they might give you a point here. And enough of you kids don't look, and you think this is 3 over. But it's counting by 2s. So be careful with something like that, all right? The second observation is it's in this quadrant over here. So some of you don't know about quadrants, but in any event, everything happening is in this area here, right? From that down. Nothing's happening over here. Nothing's happening over here. Nothing's happening over here. Okay? And these are positive numbers, and the ones here are negative numbers. All right? So there's nothing a big deal going on over there. Okay? So now what they're going to ask us to do, I don't see anything else we can grok here. They're pointing out Q, R, and S. I'm going to make a wild guess because that's the points to what looks like a triangle that they're going to ask us for the perimeter or the area of that triangle. All right? I'm not sure. Okay? So I cluttered the screen a lot. So let me get rid of a bunch of garbage I just put up there. So I'm going to label the points that they're giving us as well. So let's clean this a little bit. All right, so we're back to what they showed us. So they're telling us that Q is 6, comma, -2. And we can see that. This is 6 here, this is -2 here, and that's where it goes, all right? So you do your x coordinate first, x comma y. You have to take, you're going to move a ladder over, and then you're going to go up or down it, okay? So you can't go up or down the ladder. I mean, you can, but it's going to be of no use if you're not in the right place that you moved it over. So that's one way to remember it, that your x comma y is you're going to move it over and then go up or down, okay? R is 4, comma, -2. -7. Okay, and then S is 2, comma, -5. So I'm going to write that over here. Okay, so triangle QRS with vertices, whatever, and vertex means the corners. So it's the corners of triangle QRS is what we just wrote down, is drawn inside a rectangle. So now we're given facts. We know it is indeed a triangle. we know it is indeed inside of a rectangle, as shown below. Okay? So what is the area and square units of the triangle QRS? So if I was to shade this real quick for a second, they want to know the area of that. Now it turns out there's a lot of ways to actually solve this. Okay? Hello, I'm fine. Just chugging along. How was your test? Did you have it yet, or are you still going to have it? I know some kids are doing the test on Saturdays and after school as well. So hopefully that went well. And by the way, this could easily be a grade 7 problem, the one I'm doing right now, because there's lots of various ways. So I'm gonna unshade that for a second. Just now that it's clear what we're trying to solve here. Okay, so what is the area of triangle QRS? Well, there's a couple ways to solve this. One way is to just actually count it. So here's what I'm going to do. I'm going to expand the window for a second so that is clear. Let me just move my thing. We're at 150, 1, 2, 3, 4. Okay, I pumped this up 4 times. Right, a half means 0.5. So 0.5% means over 100. So half a percent is 0.5 over 100, which is the same as 5 over 1,000. So 0.005 is tenths, hundredths, thousandths. So yes, that would be correct. Okay. So one way to solve the problem on the screen is just to count. Okay. This is almost the whole one. Okay. This is almost the whole one. There's 2 there. Okay. This is half. So I'm going to put 3 and 3 here because together they make 1. So that's 3 so far. Okay. What else can we get out of this? This plus this looks like 4. Okay. This is a whole one, 5. Okay, and this plus this makes 6. So we have about 7. Okay, 7 seems to be the answer if we did it that way. Let me shrink this back down. 1, 2, 3, 4. Okay, so it turns out that 7 is one of the answers they're giving you guys. Well, actually, let me pop that up one more time because it looks too tiny still. There we go. So this is one way to solve this problem, to actually count that. Does this mean, so 0.005 times 2? I'm not sure where the 2 is coming from. A half a percent is actually 0.005. I'm not sure where you're getting the 2 from. So the answer is indeed 7. And if nothing else, this means you understood the problem. Okay, there are other ways to solve this. So what I'm going to do is I'm going to label the parts. And this is called the composite shape. If this was a, in fact, let me change the color of this. If this was A, this was B, this was C, and this is D. It means these 4 shapes make up the rectangle. So if we get the area of the rectangle, okay, and we subtract from it the area of triangle A, subtract from that the area of triangle B, sorry, not B, because B is what we want. Subtract from that the area of C, and subtract from that the area of triangle D, right? So if we get the whole rectangle, and we get rid of here, here, and here, then we're left with the area of the inside triangle, okay? And the reason that's okay is that this triangle B is slanted. So we can still compute the length of its sides and still get its area that way. But because it's slanted, it's a little harder to do. But that's another way to solve this, okay? So if I unclutter the screen again, in fact, I'm going to puff this back up again. Like, is 0.5% as a decimal 0.005? Yes, it's literally that. You could say 0.5% equals 0.005. So to get A, we can superimpose this rectangle here. And we can see that this is a 3 by 4 rectangle. Okay? So that's 12, and it's half of that. So it turns out that the area of A is equal to 6. Okay? And we can do the same thing for each of the others. If we do this on this, in fact, let me change the color of the pen again, just so we're clear what we're doing. Let's make that bluish. If we take this square here, this is a 2 by 2, so half of it is 1. So this was C. So the area of C equals 1. By the way, I don't know why I wrote 1 here. This was supposed to be a 6. Okay? And then the last thing we need to get is the 1 here. So let me change the color of the pen again. What's a good choice? Maybe this orange thing. So if we were to look at this here, okay, because we're trying to get that there. So that's 2 by 1, 2, 3, 4, 5. That's 10, and half of that is 5. So this would be D. So the area of D is equal to 5. All right, so the area of the 3 of these together is 12. Okay? If I did that right. Don't forget to subscribe and hit the like button. Yeah! Let's see, 4 by 3 is 12, area is 6. This is 2 by 2. Wait, I wrote 1 here. Where's my pencil? I wrote the wrong numbers here. This should be 2. Okay, so the area of the 3 of these together is 13. So I'm double checking my areas. Right? A was 4, 1/2 times 4 times 3. So it's 1/2 of 12 is 6. Okay, the blue one, which is C, is 1/2 of 2 by 2, right? So we get 1/2 of 4, and that's 2. And of the yellow one, we have 1/2 of 5 times 2, or 1/2 of 10, which is 5. So if we add up the area of the 3 of those, right? So what we're doing is we got this, we got that, and we got that. So the only thing left is the inside here in the purple. Okay? So if the area of the whole rectangle is 4 times 5, that's 20. So we would have 20 minus 13, which is 7. Okay? So that's another way to do this. All right? There's still another way to do it. let me erase the screen one more time. And I'm just gonna throw it out there for you guys as a thought. I'm not gonna actually do it because I want to get to some of the other problems. But if anybody wants to try it on their own and email me what if they didn't get 7 as the answer. Why is it not erasing that? Okay, there we go. Okay, let's get a darker pen or whatever again. So what we want to do is now figure out the sides. So if this was side A, and this was side B, and this was side C, what we could do is bring it so that let's see, how would this work? What we basically want to get is the rectangle that looks like that. Okay, figure out the area of that, and then do half of it. Okay, so what we need is the length of A, B, and C. All right, so there's ways to do that. It gets very more complicated. We know this is 2 and this is 2, so this turns out to be 2 the square root of 2. Okay, which is why I won't go it. So if anybody wants to try this themselves, this is really a grade 8 problem. Okay, at that point, but you already have 3 ways. I showed you 3 ways to solve this, so that's good enough. It turns out there's more ways to solve it. Okay, so with that in mind, again, if you want to try this on your own and come up with what you think the side lengths are, please, email it to me, whether you can figure it out or you can. But there are ways to determine what the length of A, B, and C are, and then do 1/2 BH on whatever those amounts were, right? And basically, at that point, this will be your base, and this A will be your height. Okay. So from there, you could figure out what the area of that is inside of there. But it's that's actually in this example is a slow way to do it. Okay, doesn't mean it's inferior. It's just slower. I'm just giving you guys trade-offs about some stuff like this. All right, so let me shrink this back down. Anyway, the mechanism which you showed, the answer was 7. And remember, on some of these, you can just count it. Just count the boxes. Just do it slowly the way I did it originally until you have something that's looking and making sense. Okay, let me shift this back because I think this is lined up somewhere else. Okay, there we go. Okay, so we have another coordinate geometry one. And let me just see how much time we're going because I'm starting to run out of time. Yeah, I don't know how many more problems we're going to do after this. But let's see. My screen is still cluttered. Give me one more second, guys. I'd like to do a few more because I don't want part 4 to be too long. And again, if anybody's catching this, like Hang Jun did, good luck on your exams. I know New York is having them, and probably others are. And we're getting close to the end of the school year, so you guys should be bumping up your A game and stuff anyway. So we have again another coordinate geometry. It's not showing us the parts here. We're not saying this, or this. Okay, the units are 1. Always note that the units here are 1. Cool. This is your X. This is your Y. There's a point G somewhere, and there's a point F somewhere. Okay, so let me get rid of everything I just drew. Okay, normally it doesn't matter, but let's just do it anyway. So we're going to go over first, then up. Remember, we're going to move the ladder and get our X. So it turns out that that F is 3, 2, and G is 4, 4. Okay, can't see that, you got to, right? Dwell on it a bit until you consider that case. All right, so there's really nothing else going on here. We don't have no idea whatsoever what they're going to ask us. All we basically did was figure out what the coordinates of those 2 points were. Okay, point F and G have been plotted. Cool, big deal, whoopsie-doo, on the coordinate plane below. Okay, so that's not helpful. Let me just squish this up slightly because the answer choice number D is not showing. And by the way, it's often a good approach to these problems is to not look at the answers. Make believe it's a grid-in or an open-ended question, because sometimes the answers help you and sometimes they lead you astray. Okay, so that's something there. So let's look at here and see what they're actually asking us to do. Point G and point H are the same distance from point F. Wait, where's point H? Okay, what coordinate could be the location of H? Ooh, interesting. So it's saying point G and H are the same distance from F. So whatever this distance is here, there's some other point there. Okay, so one way to kind of approach this, and I'm gonna do this, you know, loose-handedly, is that you basically, for it to be within that distance, and I'm doing this real sloppy, it has to be there, right? So H is not going to be over here. That's no good. H is not going to be right there. That's no good. H is not going to be right there. It's got to be kind of within that area there. So even if you don't know how to solve this mathematically, you should be able to solve it visually and logically. Okay? All right? So even with that in mind, like A says it's 1, 2, right? So if that's there, it would be there. So that kind of looks like it's possible. We'd have to figure it out. Okay? B is 4, 2. Okay? So it can't be B. B is too close. Okay, C is 5, 1. That's about there. So that's within the realm of my sloppy circle. And D is 2, 5. Okay, even though my circle's sloppy, it can't be D either then. All right? So visually, if you don't know anything else to do from here, you went from 25% down to a 50-50 chance of getting the right answer now. Okay? So how do we determine which it is? Okay, it turns out we can still visually play games with this, because we noticed to go to G, it went over 1 and up 2. Right? The problem with 1, 2 is it only goes over 2. It doesn't go up or down 1. So for that reason, it can't be A. Let's make sure our logic is making sense if we go to C. C says it's this point right here. So this is down 1 and over 2. Right? Do you all see that? In fact, let me change the color of the pencil again. Right? Our goal was to go 1 and 2. Okay? To get to here, it only goes over 2, so it's not that. To get to this point here, it does go 1 in one direction and 2 in the other. So that's the reason why C would be the answer. Okay? The other way to figure this out is to figure out the distance between F and G. Okay, that's normally a complicated thing. We can calculate that. Okay? Because we know this distance here is 1 and that's 2. So we can use the Pythagorean Theorem and get the distance here. All right? And again, if somebody wants to try that route, please try it and see if you get the same value, because this is 1 and this is 2. So that means that's there. Okay, and if you look at both of these, by the way, and I'm going to change the color again. Let's do this light blue here. If we draw this here, the hypotenuse is just the diagonal here. Okay, and if we draw that same thing this way, if we lean that rectangle on its side, it's still the diagonal. So we don't even need to compute the number. We know it's the diagonal. But if anybody wants to go and actually compute what the diagonal is, you know, feel free to go ahead. Because it gets ugly. At least I think it does, if I'm calculating it right in my head. So that's basically what's going on there. All right, so that's that one. And again, the next page might be the last we do. Let's see. Okay, there's no illustration on this one. George spent $23, or he has $23. He hasn't spent it yet. He has $23, and he's going to spend it on art supplies. He wants to buy markers, paper, and glue. If the total of the markers and paper is more than 14, which inequality represents the dollar amount? So equalities are like x equals 5. Okay, and inequality is going to use less than, greater than, less than or equal to, greater than or equal to, or not equal to, which is an equal with a slash through it. Okay, so these are the inequalities. Okay, so which inequality, and if you notice, the choices here are only using these two, which is fine, represents the dollar amount P that George can spend on glue. So let's go through this one more time. He spends $23. Sorry, he has $23. Okay. He wants to buy markers, paper, and glue. Okay. If the markers and the paper is more than $14, right? It's more than $14. So let's ignore the glue for a second. If he went into the store with $23 and he only bought the markers and the paper for more than $14, and he paid what if he has 23, what can he be left with? If they were exactly $14, he'd be left with $7. I mean, sorry, he'd be left with $9. Let me restate that. I just said 7. I don't know where he got 7 from. If they were exactly $14, if the markers and the papers cost exactly $14, right? 23 minus 14 is 9. So he would get $9 change. Since he paid more, right, is more than 14, then he has to get less than $9, like $8 and something, right? And that's what the problem is asking us to do. He spent $23 on supplies. He buys markers, paper, and glue. The total of the markers and papers, whatever. What represents the amount he has left for the glue? He doesn't have $9. He has less than 9. It's $8.99 down, right? Because this could have been $14.01. All right? So which represents less than 9? Well, obviously is A. Okay? Okay, 17. And by the way, you double check for here is just to make sure that the 9 is realistic, that you actually did 23 minus 14 in some reasonable way. Okay. Okay, we're going to look at this thing here. We see this weird shape. Again, it's a composite shape, which means it's built up from other shapes. Normally, when you see these dashed lines, it probably means something's being folded. And if you fold all these up, you kind of get like a shoebox shape, right? Which is called a rectangular prism. Okay, and they seem to be giving us the dimensions of the areas of each of those little surface areas. Okay, so it's trying to tell us that this here if I was to cut that off by itself, the area of that is probably, and it says square centimeters, So we can have an idea that's probably what's going on here. Again, we're only looking at the illustration. We're trying to make sense of it. And each one has it. That has one, that has one, that has one, that has one. And the so-called wings have one too. Okay? So imagine it's like an airplane shape, if you will. Even though it's folding into a rectangular prism. A shoebox shape, if you will. Okay? So you're going to fold this up. If I call this A and B, we're going to fold A and B up on the side. This is going to fold up, and this, when we fold it, that will meet. This will meet, okay? When we're going to fold this now, so this and this will meet, okay? So now we have basically an empty box with no top, and this will be the top here. So I'm going to call that T, right? Can you visualize that, guys, if you fold this back up? So what we basically have is a sheet of paper that's in 2 dimensions that when we fold it up makes a 3-dimensional shape that's hollow on the inside, right? So this would be a container. Theoretically, if it was made of plastic or something and we sealed it properly, we could fill it up with water or something like that, all right? I'm not sure what else is going on here, and we actually don't know that they're eventually going to fold it up, but if you did this transformation in your mind and even got a piece of paper with this and folded it up, that's what would be going on there. We don't know why they're giving us these numbers, but we can notice patterns that the 12 here is the same as the 12 here. So when we fold it, the lengths of the little short sides on the sides are going to be the same. If this is the one side here that's 18, right, then this over here is also going to be 18. Oh, wait, sorry. Ignore that for a second. I made a misstatement. Okay, but it means whatever this length is, I'm going to call this L, that this is L. Okay, and then since this looks like it's a rectangle, this is probably L2, and that this is probably L. Okay, and if this is L over here, then this was probably L, and this is probably L, and this is probably L, and this is probably L. Okay, and if you notice, this was 24 and this is 24, because shouldn't the top be the same as the bottom? Shouldn't they be the same size? If this turns out to indeed be a rectangular prism, and shouldn't side 1 be the same as side 2? If they're the same, so that's why a lot of these numbers are here this way. Okay, so I'm going to call this length here H. So most likely this H is this H, and then this H. Okay. Okay, so with that in mind, the net of the rectangular prism is shown below. The surface area of each face is labeled. So this is the surface area. Okay, so it says what values represent the dimension in centimeters of the rectangular prism. So what we're trying to figure out is what those L's and H's and stuff were. All right. So what we're trying to do is do the factors of 18. So we have to make some guesses here. So if this was 6 and this was 3, right? Then if this was 3, then this was 4, which means this is 3 as well. All right? And if this is 4, then this is 6. So it jives again that we got the 6 right. So that's 6, that's 6, this is 3, this is 4, this is 6, and it all jives. So that's the numbers we're looking for. Okay? And we get 3, 4, and 6, which is the numbers we came up here. 4, 3, 6. Okay? All right, guys, I have to cut out. I just got the message that I had to leave. So I'm going to wish you guys all a peace out, and we'll continue this part 4 at another time. Please subscribe, please like, and live long and prosper. Goodbye.